Welcome to this discussion about solving linear equations. Okay, so we're going to focus our attention today on solving two kinds of linear equations. In this video, we're going to focus on solving linear equations that have no fractions. Okay, so I have on the board here an example of a linear equation. We know it's linear because the variables have no power greater than 1. All right, and so we see variables and we see values, but no variable has a power greater than 1. And so when we see this, what we want to do is we want to group all the terms that have a variable in it to one side of the equal sign and everything else to the other. Now, in this particular case, there's an awful lot going on, so we're going to clean it up before we start moving things around. Let's go ahead and get rid of all our parentheses by distributing anything through that can be distributed through. So 5 times x minus 2 times 3x plus 1 is equal to 4 times 1 minus 2x plus x. We can distribute through this 5 to both these terms. We can distribute the negative 2 to both these terms. And we can distribute the 4 to both these terms. Let's go ahead and do that. Okay, so when we've done that, we end up with this. 5x minus 10 minus 6x minus 2 is equal to 4 minus 8x plus x. Got it? All right, so now let's take, there's still a lot of stuff going on. Let's take both sides of the equation and simplify just those sides of the equations. So 5x minus 6x is going to be negative 1x, which we can just call negative x. And we've got negative 10 minus 2, which is going to give us negative 12. And then on the right-hand side, we've got negative 8x plus x, which is negative 7x plus 4. Okay, so now, let's bring all the x's to one side of the equation. Doesn't matter which side, just bring them to one side. So let's bring this negative 7x to the other side. And the way we do that is not just magic. We're going to add a positive 7x to both sides, because the effect of that is this negative 7x and this positive 7x negate each other, and that becomes 0. We're going to do the same thing with this negative 12, except this time we're going to add positive 12. And again, that negative 12 and the positive 12 become 0. So what I have here is 6x is equal to 16. Now, once I've got it in this form, all the x's to one side, all the constants to the other side, then we're just going to divide out the coefficient. So I'm going to divide out a 6. So I'm going to divide out the 6, and I end up with x is equal to 16 over 6. And that 16 over 6 can simplify to 8/3. Let's do another couple of examples. Okay, second example, very similar to the first. 2 plus 5x minus 2 times x plus 1 minus 6 is equal to x plus 3x minus 5 minus 4. Okay, so again, let's clean this up a little bit. Let's get rid of all the parentheses. Let's combine the like terms on both sides, and then let's separate the x's to one side and the constants to the other. Okay, so now I've gotten rid of all the parentheses. I've taken that negative 2 and I've multiplied it through to x plus 1, and it became negative 2x minus 2. And here, the set of parentheses I have had nothing in front of it. So I had nothing really to get rid of, because really that's a 1 multiplied by that set of parentheses. Okay, so no parentheses. Let's combine all the like terms on the left and all the like terms on the right. Okay, when I combine all my like terms, I end up with 3x minus 6, because I've got 5x minus 2x is 3x. 2 minus 2 minus 6 is negative 6. And then on the right-hand side, I've got x plus 3x is 4x, and then the negative 5 minus 4 is negative 9. Now I'm ready to push all the x's to one side and all the constants to the other. So I can subtract a 4x on both sides, and I can add a 6 to both sides. Okay, when I combine this, I end up with negative x is equal to negative 3. Well, that's close to what I want, but I really want what x is equal to. And so if I know if negative x is equal to negative 3, then positive x will equal positive 3. And I can actually get this algebraically by dividing both sides by negative 1. Okay, and I can also go through and double check. If I substitute this 3 in to all the places where I see x, I will end up with the same number, the same value on the left side of the equation as I do on the right side of the equation. That's what it means for a value to satisfy an equation. Because when I sub it in, I get the same on the left as I do on the right. Let's do one more example, and this time, if you can stay ahead of me, that's even better. Try to stay one step ahead and see how you do. Okay, last example of this kind. Like I said, if you think that you can move one step ahead of me, go for it. All right, so go ahead and pause the video and see what you can do with the first step. What is that first step? Hopefully, it's removing the parentheses. So distribute anything that can be, and then restart the video. Okay, so double check. Did you get negative 4n minus 5 plus n is equal to 49 minus 49n plus 6 plus 36n? Hopefully you did, and that'd be correct. Next, combine like terms on the left side and on the right side. Pause the video, see how you can do. Okay, if I combine all the like terms on the left, I end up with negative 3n minus 5. And if I combine all the like terms on the right, I end up with negative 13n plus 55. Now I'm ready to push the variables to one side and the constants to the other. Pause the video, see how you do. Okay, when I do this much, I end up with 10n is equal to 60. And now when I divide out that 10, I should get my answer. N is equal to 6. And it's true. When I sub that value of 6 into my equation, I will end up with the same thing on the left as I do on the right. Do you know what that value is? Try to check your answer and see if you get the same thing on the left as you do on the right. I ended up with negative 23 on the left and the right when I subbed in that value of 6. Give it a shot. In the next video, we're going to talk more about solving linear equations, except this time we're going to add our favorite math F word, fractions.